Hello all, welcome to this course on Elements of Mechanical Engineering. My name is D.A. Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Now in this lecture, we are currently in the fourth module where we are discussing different milling operations. In the previous lecture, we have seen 6 types of milling operations. Now let us see the remaining milling operations in this lecture. So we have seen so far 6 milling operations, that is flat milling, face milling, angular milling, and then gang milling. And apart from these milling processes, we have seen some 2 other milling processes. And now we are going to see the remaining milling processes which are possible in the case of a milling machine. This is related to milling machines only. The type of the milling machine is same, but we can operate different types of processes by doing or changing the tools. Okay. Now, the 7th type of milling process, that is slot and groove milling process. So see here, slot milling is the operation of producing slots in the solid workpieces. These slots can be of different shapes, such as plain slots, T-slots, dovetail slots, etc. So these are the different types of slots that are possible for any slot and groove drilling machine. Okay, we can see in the picture, this is a plain slot. So we have a workpiece, this is the workpiece, and in the workpiece, we can actually make slots. Okay, we can actually make grooves. Okay, suppose if this is the length of the workpiece, so we can create a slot like this. Okay, we can create slot through the length of the workpiece by using this slot or groove milling machine. Now see here, this is mostly used to make plain slots, T-slots, dovetail slots also. Okay, plain slots are nothing but this is a plain slot. Okay, if we have other workpiece, this is dovetail. This is a dovetail slot. Okay, it is in the dovetail shape. Okay, and then we have T slot. T slot is nothing but it will have some T shape here. So this is a T slot. It is in the shape of T. Okay. Why do we need these type of slots? Because we have to insert some kind of a screw into this so that it requires this particular shape. Okay, dovetail joint, dovetail slot also has some applications for locking mechanism. Okay, so these are the different types of slots or grooves that can be performed by this slot and groove milling machine. So plain slot can be milled by using plain milling cutter and end milling cutter. There are 2 types of milling cutters available. They are plain milling cutter and end milling cutter. So by using any of these milling cutters, we can do plain slots. Plain slot is nothing but which is shown in this picture. This is a plain slot. It is in rectangular shape and it is cut throughout the length of the workpiece. These are also made throughout the length of the workpiece. Okay. Groove milling is the operation of producing grooves of various shapes like plain grooves, curved grooves, V grooves. And then we have other than plain grooving or plain slotting, we have other operations that are possible, like we can make V-shape grooves are possible, or we can make curved grooves like this, semicircular grooves can be made, or we can make V grooves. V, plain and curved grooves. So these are the different types of grooves that can be made with the help of this slot and groove milling machine. And according to the shape of the slot or groove, the cutter is selected. Okay, depending on the shape, we have to select a particular tool. I cannot do V groove with a plain slotting tool. Okay, I have to take a V tool in order to make a V groove. In the first stage, open slot is milled by using suitable cutter and then the slot is milled by using special cutters like T-slot milling cutters. So generally what happens is, if I want to make a V shape, or if I want to make a, suppose I take the example of a T shape groove. I want to make this groove. Initially what I will do is, I will take the workpiece and I will make a rectangular plain slot. In the plain slot, for making this plain slot, I need a normal end mill cutter. Okay, I will simply make a slot which is in rectangular in shape. Then what happens? I will take a separate tool which is more in diameter. The tool cutter will be more in diameter. Now, using that diameter, using the second tool, I will make groove here. Now this will increase the diameter. Okay. Now this is the final output. Okay, I have to redraw this. So this is the final output. So I have completely converted the rectangular slot or plain slot into a T-shaped slot. Okay. So depending on the type of slot I have to prepare. Initially I have to prepare simple shape like rectangular or semicircular. Then I have to convert it into required shape. Some special shapes like dovetail shape, etc. They cannot be done like this. They have to be done in a single process. They don't have two stages. And then eighth type of milling operation is keyway milling. So keyway milling is common operation which is performed on milling machine. In this, groove is milled on shafts and spindles. So keyway milling is nothing but milling a keyway on the workpiece. So this is mostly done on shafts and spindles, because if there is a shaft is generally rectangular, it is a cylindrical object on which we have to make this slot. So this slot will be throughout the length of the cylinder. Okay, if we want to make slots, we have to use the process called keyway milling process. So for shafts and spindles, we have to use this. Why do we need this key? We have to insert a mechanical element which is made exactly the size of the key. This is called a key, and this key element will be inserted into the shaft for locking. So sometimes shafts will be inserted in between two wheels, where we have to insert this key in order to lock it. If we want to remove the wheels from the cylinder, like if this is the cylinder, I want to insert one wheel on this side, other wheel on the other side. So I have to insert this key so that the shaft, when it rotates, the wheels also will rotate. Okay, this is very similar to the railway wagon. So if I want to remove the slot, if I want to remove the two wheels from the shaft, I have to remove the key. So this is the key, this is a wheel, and this is another wheel, wheel 1 and wheel 2, and this is the shaft. So if I want to remove the wheels, I have to separate the wheels. First of all, I have to remove the key so that the wheels will be removed easily. So, which is known as a key seat. So this key seat will be grooved or made in the keyway milling process. Okay, figure shows this different types of keys. So see here, this is the keyway that is milled on the surface of the workpiece. A woodruff key seat which is milled with woodruff key seat cutter. Sunk key seat which is milled with the end milling cutter. So there are two different types of milling tools that are used for different operations. That is, sunk key is milled with end milling cutter, and woodruff key is milled with woodruff milling cutter. Okay, these are the different types of tools which are used for particular type of milling process. And then ninth process is slitting or saw milling. Slitting or saw milling. So saw milling is the operation of production of narrow slots or grooves on a workpiece by using a saw or slitting milling cutter. Remember the name of this machine, slitting milling cutter. So the slitting milling cutter or a saw is used to groove narrow slots Okay, narrow slots are to be made on the workpiece. Then we have to use this. So in the picture we can see this is a saw. This is a very thin plate. Uh, this is not suitable for wood. This is used for cutting metal itself. So we have to use this saw, and this saw will be rotating at higher speed along with the spindle, along with the arbor. So this will make very narrow cuts on the surface of the workpiece. Okay, then only we should go for its slitting or sawmilling. So slitting will produce very narrow grooves or very narrow cuts on the workpiece. It is also used for complete partition of separation. So sometimes we can keep on doing this process. If we keep on cutting the metal with this operation, okay, in this process, what happens? The entire workpiece can be divided into two pieces. Okay, so generally we will use this saw for cutting wood into pieces. Similarly, we can use the same saw for cutting metals also. This is not a general procedure for cutting of metals. We have other techniques which are more effective, but this process can also cut the metal into two pieces where there is no loss of metal, whereas other milling process will remove a large amount of chipping. Okay, here this saw or the slitting milling cutter will be very thin in size so that it can be used to groove narrow cuts, or it can be used to cut the workpiece into two parts. Okay, so the cutter and the workpiece are set in such a way that the cutter is directly placed over the one of the T slots of the table. So mostly in T slots, this type of operations are done. We have to use, in order to make a T slot, we have to use this tool. So I will show you. Initially, this is the workpiece, and this is the area. On this, I already have a slot. I have to prepare a T-shaped slot in this direction, inverted T. So what happens? I will initially groove small T shape with the help of this slitting saw, and then after that I will do this process. Okay, this is how T slots can be easily done on this slotting or saw milling machine. Okay, so this is a operation. This is a type of operation. And then let us go for 10th one. So 10th one is nothing but side milling operation. So in this operation, a side milling cutter is used for machining a flat vertical surface on one side of the workpiece. Okay, see here, a slide milling cutter is used for machining flat vertical surface on one side of the workpiece. If this is the workpiece, okay, that is the workpiece, and we have two cutting tools, 1 and 2. This is 1 and this is 2. So these two tools will be rotating at the same times along with the arbor. This is arbor. So along with the arbor, two cutting tools will be rotating. The only two sides, suppose if this is a workpiece, so if I use this side milling process, I can mill this side as well as the hidden side. This hidden side can be milled. These two sides can be easily milled with the help of this side milling machine or side milling operation. We can do a groove milling also. Okay, we have seen in the previous lecture, one of those processes can be done easily with this. Okay, so when two parallel vertical flat surfaces are required to be machined, then two side milling cutters in pairs are used. So if you want to use a single cutter, we can use where we can get a single side which is finished. If we want to use if we use two cutters, we can machine two surfaces at the same time so that we can reduce the production time. So by using spacer, the space between the two cutters can be adjusted. So these two cutters can be adjusted with the help of a spacer. This is also called as something called as belt, which is placed between these two so that it will separate the distance between the two cutting tools. Hence the operation is similar to straddle milling. So we have this straddle milling in the previous lectures, where the two cutters are separated with the help of a separator, that is also called as a spacer. Okay, so the side milling is done to mill the sides of the workpiece, one side or both sides at the same time, by using two cutters. If one cutter is used, only one side will be machined. Okay, this is side milling process. And then the 11th one, end milling process. So what is end milling process? This operation is used to machine and produce a flat surface or a pair of flat surfaces by using end milling cutter. So in this process, we can use a end milling cutter for producing a flat surface or pair of flat surfaces on the workpiece. Okay, this is a end milling cutter. This is used to create a flat surface on the workpiece, or at the same time we can do multiple flat surfaces also by using multiple tools. So the figure shows the end milling operation in which flat surface is produced with the help of an end milling cutter. So flat surfaces are being, so this is a flat, what is this called? It is a flat groove. Okay, so this is produced with the help of this end milling cutter. The surfaces produced may be horizontal, vertical, or inclined with respect to the top of the machine table. So we can produce any type of shape of the cut, like vertical shapes or inclined or horizontal shapes can be easily milled with the help of this end milling process. Okay, this is end milling process. We can get any orientation, vertical, horizontal, or inclination. And then the next one is profile making. So we have to understand this profile making very clearly, so that we'll go slow. In profile milling, the profile of a template or a cavity shape of a master die is duplicated on the workpiece surface. Okay, so far we have said that in profile milling, the profile of a template or a cavity shape of a master die is duplicated on the workpiece. The cutter movement is guided by a tracer control unit which carries a contact finger. Okay, the cutter movement will be followed by, that is operated with the help of a contact finger. And then the finger runs in contact with the outline to be duplicated, and the tracer mechanism guides the tool accordingly. Okay, now let us try to understand if these two are the workpieces, and also we have two tools. This is tool number 1 and this is tool number 2. This is workpiece 1 and this is workpiece 2. Now what happened? Initially what we will do is, we have to take the template of the cavity shape, okay, on the workpiece. Then what we will do is, we have to make the cutter movement while tracing the template. Okay, the movement of the cutter will be followed by the movement of the tracer. How this tracer will be moved? Tracer will follow the template. I mean, if suppose this is the object which I want to make, this is a semicircular shape to be machined on the workpieces. There are two workpieces. I will arrange the two workpieces. These two are done by two different tools. They are cutters. These two are cutter 1 and 2. So the cutters will be connected. Both of them are interconnected, and in turn they are connected to a tracer. Tracer is a device which will follow the actual shape of this. Okay, this is in contact with this one. Okay, the tracer is the device. This is tracer. So the tracer will be in contact with these two tools. So the movement of the tracer will be replicated here. Okay, so this is very hard to understand. That means, like, when we want to make duplication, we have to act somewhere and we have to duplicate it. Okay, now similarly, here what we are doing is we are studying the profile at this point from a standard template. We are studying the path through which the body has to be machined, and this path is being replicated or duplicated at different working tools. Okay, that there are two working tools here. We can have multiple tools because if we want to manufacture a large number of products which are of the same dimensions and size, we have to do same set of operations. That is why we can do multiple tool duplication, that is multiple profile milling, by studying the original shape. Okay, the cutter movement is guided by the tracer control unit which carries a contact finger. Okay, so this is tracer. So this is very similar to something what we call a robotic movement or CNC movement. So here we have a cutter control, tracer control unit, which will control the movement of all the tools in different workpieces. But all the workpieces will be machined according to the shape of the template only. Okay. So this finger runs in contact with the outline to be duplicated, and the tracer mechanism guides the tool accordingly. So whatever the movement that is given here at the tracer, that movement will be duplicated at all the tools. All the cutting tools will move same, just like in the movie of robot. So all robots which are standing in a group, they will rotate their heads. Okay. Similarly, this is profile milling, which is controlled by a tracer control unit. This tracer control unit will operate, or it will move all the workpieces or the tools in the same manner. And then the 13th process, this is gear milling process. So let us see what is gear milling. So this process is used for cutting gear teeth. Suppose I have a disc. I want to make a gear on this disc. I have to use some milling process called gear milling process. So generally spur gears are made by this process. So spur gears are easily produced on plain and universal milling machines. For cutting helical, worm and bevel gears, dividing heads are required. So spur gears are easily manufactured by using this gear milling process. So here the figure shows that the cutter is mounted on arbor, which is axis is right angle to the workpiece. See here, this is the arbor on which we have a cutter which is arranged, and this is in right angle with the workpiece. We can see in the front view. So this is the wheel. This is the wheel on which we are going to cut, which we are turning it into spur gear. So see here on the spur gear, the axis of rotation is perpendicular to the axis of rotation of the spur gear. Spur gear will be stationary in this condition, but the axis of rotation of the tool is perpendicular to the axis of the spur gear. Okay. So cutter is properly adjusted so that its central line is radial with the blank. So the central line of the cutter is in radial direction with the blank. So this area is called blank. So whenever we are preparing a spur gear, it will have teeth. The gap between two teeth can be called as blank. The tool should be placed in this blank exactly so that we can remove the excess material. We can actually cut the tool. We can actually make spur gear teeth on this process. So cutter is properly adjusted, and the knee is raised to adjust the required depth of the teeth. So the knee is adjusted to get the required depth of the teeth. So the teeth depth is required. We can do that. Okay. And in a single pass, one tooth is finished and table is returned to its starting position. So in a single step, what it will do, it will go on cutting the teeth. So the teeth shape will be cut like this. And after that, it will go to the next set of process. Before that, we have to change or adjust the wheel process, wheel orientation, so that it will cut another set of tools, set of teeth on the coming part. So this is gear milling, where we can easily mill spur gears. Okay, we can easily make spur gear arrangement on this. And then we have thread milling. So this is thread milling. This is a process of cutting screw threads with the help of a forming cutters. Both internal and external threads can be milled. Thread milling is associated with single or multiple cutters. A single form cutter has a single row of annular teeth which are lying in one plane, while cutting a cutter is tilted through a helix angle of the thread to avoid interface during the cutting. So see here, we have tools here. This is a metal object on which we are cutting threads, and here we have, this is the cutting tool which is inclined. It is not vertical, it is slightly inclined so that we can get helical angles. Helical threads can be easily cut on this surface. So this is one process, and this is another process on which we have a hob. This hob is having cutting threads. So this is so strong. Generally it is made up of a carbide or a ceramic, where the movement of this workpiece on the tool will create threads. Okay, this is the side view. We can see this is a normal cylindrical rod on which we are cutting threads. So the cutting threads on the hob will be very hard. So this is a cutter which will create threads on the workpiece. Okay, so mostly to create the helix angle, we are going to use this inclined tool orientation so that we will get thread milling very easily. So during the process, the cutter is fed radially inward up to the required depth of the thread, and workpiece remains stationary. So in most of the cases, workpiece will remain stationary, but it is not suitable because we have to cut in a radial or spiral manner. Now the job is rotated slowly, and cutter while rotating is also traversed along the parallel to the workpiece. So workpiece has to be traversed along the length, okay, so that we can get the required amount of thread cutting on the workpiece. Okay, so thread milling is used for cutting coarse threads as shown in the figure. Thread milling with multiple teeth cutters is shown in the second figure. So this is here we can get, this is coarse, C-O-A-R-S-E. This is coarse and this is fine. So here we can get very evenly spaced, very large gap threads will be formed in this first figure. Okay, we can get coarse threads here and we can get fine threads on the second figure. So depending on the type of threads we want to create, we have to select particular tool. Here for coarse threads, we will use a single point cutting tool, whereas in fine threads, we have to use a separate thread machine or thread tool, which is called as hob, and this is rotated, and while it is rotating, it will create threads on the workpiece. So these are the different types of operations that can be performed on a milling machine. So far we have seen 14 milling machine operations. We will meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.